Lesson 8.3a, Theoretical and Experimental Probability. The probability that we have studied so far is called theoretical. It's in theory, things happen that way. But we all know that if you flip a coin 10 times, there's no guarantee you'll get 5 heads and 5 tails. It just doesn't work that way. But theoretically, it's supposed to be that way. All right? So we talk about that, and then we look at something called experimental probability, where experiments are actually done. They record the results, and then you make predictions based upon that. So experimental probability that we're going to look at today, there's been experiments, you figure out the probabilities of those things, and then we'll take it further and make predictions. So look at example 1. It says the graph shows the results of an experiment in which a number cube was rolled 100 times. It's important that you know the total number of times. So the number cube was rolled 100 times. The graph shows how many times they rolled each number. How many times did they roll a 1? 14. Okay, so the bar on the bar graph shows how many times for each number. Which one came out the least amount of times? 2. Came out only 13. Which one came out the most? 5. Okay, so that was their number cube experiment. Now, it says find the experimental probability of rolling a 3 for this experiment. So the probability of a 3, the number of times a 3 occurred out of the number of possible times. So the number of times the 3 occurred, if you look at the 3, it's 16 on top, and there was 100 times for the number of possible on the bottom. So 16 out of 100. Make sure you always reduce that 4/25. 4/25. That's the experimental probability. That's the experimental. And it's saying that it's close to the theoretical of 1/6 because the probability of rolling a 3, there's 1 3 on 6 sides. So it's not too far off actually. Example 2. This is where I say you take their experiment and make predictions from it. So, well, not yet. This is still another experimental, I guess. In a telephone poll, 225 people were asked for whom they planned to vote in a race for mayor. What's the experimental probability of Juarez getting a vote from a person selected at random? So all of these people voted, and it said there was a total of 225. Juarez, if you look, how many people voted for him? 75. So the probability of somebody at random voting for him, 75 over 225, it reduces to 1/3. Now we're going to make a prediction. So that was just a poll based on 225 people. Well, when they really vote, they said suppose 5,700 people vote in this election. How many can you expect to vote for Juarez? So since the probability for him in the experiment or the poll was 1/3, if you take 1/3 of the 5,700, they can project that there'll be about 1,900 votes for Juarez. Have you ever wondered how before an election they make projections of how many people they think are going to vote or how well a candidate's doing? They do these polls, and sometimes the polls are accurate and sometimes they're just completely way off. So you can't really rely on them 100%, right? Just like regular probability, you can't rely on it 100%. But that's how you make projections. So we're going to look at an example. There's only one for us to do for this, and it's pretty simple. It says there was a survey of 150 students, and they were asked just simply if they prefer cats or dogs. So 150 students, how many preferred cats? 18, only 18. And then the remainder, 132, preferred dogs. So what's the probability of a student preferring dogs, Dylan?
132 over 140, I believe. 50.
So 132 over 150. Does that reduce, Dylan?
Yes.
Yes. Any see what you want to divide out of it?
I'm going to say 1 over 2.
So divide them both by 2. Okay, so that looks like to me it's going to be over 75. And if I take 132 divided by 2, it's going to be 60.
It is 61.
61? No.
66.
66. Now, Dylan, does anything divide out of 66 and 75, you think? Huh? No?
Oh, wait.
What do you think? What would go into 66 pretty easily? Can you tell?
2.
2, but 2 doesn't go in 75. What else goes into 66, Dylan?
3.
3. How do you tell if 3 goes into 75? Anybody know? Quarters? Ooh, quarters. 75 cents. That's 3 quarters, isn't it? Anybody, and that's true. So it does divide, 3 does go in there. Anybody know the other way? We've talked about it in here before. The divisibility rule for 3s. You take the digits of the number and add them up. And if it's a multiple of 3, then 3 goes into it. So what's 7 plus 5? 12. Does 3 go into 12?
Yes.
So 3 would go into 75. That's how you tell. That's a divisibility rule for 3s. But yeah, let's divide them both by 3. So it's going to be 22 over 25. You think that's as low as it goes?
No.
Anything go into 22 or 25? They have in common anything?
Nothing.
No. So the probability that you're going to pick a dog at random and they prefer a dog is 22/25. Now we're going to make some predictions. Suppose 100 students were surveyed. How many can we expect to prefer dogs? I'm going to show you how to set up a proportion. I think that would be much better. So if 22 out of 25 prefer dogs, we want to know how many out of 100.
Will we multiply?
Yeah, we've done problems like that. What should I put up there where the question mark is?
X.
An X. Let's put the question. Let's make the question mark an X. And Dylan, how do you solve that?
You have to cross multiply.
Cross. So 22 times 100
Is 2200.
and 25x. So 2200.
It's 25.
And then what's the last step?
Divide by 22.
Divide both sides by 25. So if I take 2200 divided by 25, I get 88. So we would project or predict that 88 people, 88 students out of 100 would prefer dogs. So 88 students. All right, suppose out of 300 students surveyed, how many would we expect to prefer cats?
Not very many.
Well, first of all, how many preferred cats out of our original 18 out of how many? 150. So now we're going to do, just a minute, 18 over 150. Now we're going to say how many out of 300, right? And make that question mark an X, cross multiply again, or what are you thinking, Jacob?
You can take times 2.
Times 2. Look at that. 150 times 2 is 300, isn't it? What's 18 times 2?
36.
There you go. So 36 students would prefer cats out of 300.
What do you take that divided by 2?
Because it was one out of 150 originally, and then now we're doubling the number of students. So you would double the number that liked cats. So now there's 36. So you're going to find probabilities based on experiments, and then you're also going to take that information and make predictions about different numbers of the groups. So you're going to set up some proportions and solve. Are there any questions?